All right, it's Ken Rosever. We're going to talk about sample standard deviation again. This is the second video. In this video, I'm going to introduce you to the alternative formula. It's the shortcut formula. It's found on page 137. The formula I taught you last time on the previous video, let me go back, was this one right here. Um, this formula involves you having to first take all the x's. Let me switch to the pen. Take all the x's and take the difference between those x's and the mean. Um, add up the square of those differences, which is this right here. The sum of find the squares of those differences and then add them up and then take that number and that goes in the numerator and divide it by n minus 1. The new formula, which I'm going to show you with this problem, involves some similar notations, but is a little more calculator friendly. Here we go. It says the standard deviation is equal to the square root of this quantity n times the sum of the x's squared, the sum of the x squareds, minus, parentheses, the sum of the x's squared. Notice these two things are different. One says we square everything first before we summate it, before we add them all up, while this one says we add everything up and then we square the result, divided by n times n minus 1. You'll note with me that this one doesn't have an x bar anywhere in it. But this one is very, very calculator friendly because you can do all this in your ALEKS calculator. I'm going to do it right here though. I'm going to first of all point out that n is equal to 5. Next I'm going to do the sum of the x's. If I add these all up, it's easy to see that 55 and 55 is 110, 49 and 51 is 100. So I have 110 plus 100 plus 50, which is 260. So that is my sum of the x's. However, sum of the x squareds is not something I can do in my head, but that's where the ALEKS calculator is really helpful. So let me just switch over to here and I'll show you how to use that ALEKS calculator to do the same thing. Here's a calculator, okay, and I'm going to go back to this. Well, let me show both. No, it won't. Okay. You remember, I hope, that it was the sum of the x squareds. Now, rather than squaring everything and then adding it up, what you can do, which is really nice in ALEKS, is you can click on the first number and drag. It'll input all those, and then you can just hit sum of x squareds, sum of the squares, and there it is. Okay? So going back to here, I now know that it is equal to 5 times, what was that? 13,552, 13,552 minus 260 squared all over 5 times 5 minus 1. And then you just simplify this. 5 times 1352. I'm going to pause for a second. Just wrote that down on a sheet of paper. And you would normally be working with a scrap piece of paper, so you'd have this in front of you. It's just unfortunate I can't make them show up on the same screen. So this is what I'm going to now calculate. Before I do though, I'm going to do one more thing here. Let me clear this and then select these again. Now watch. Just to double check my 260, which I said was the sum. There you go. You see how easy that is. Okay, so I need to take the square root of a pretty big quantity. The quantity is, I'm taking the square root of everything. I'm going to use a double parenthesis here, and I'm going to go 5 times 13,552. And even though I really don't need a close parenthesis there, I'm going to, actually I'm not going to, am I going to do it there? No, I'll leave it off. I'm going to go minus, and I'm going to do 260, and I'm going to square that. And then I'm going to close that parenthesis, divided by, what do I need to divide it by? 5 times 4. And then I'm going to hit to the right tab, and close that parenthesis. Now, that's how you enter it all in there at once. If you didn't want to enter it all at once, you could do it piece by piece by piece. Evaluate what's 5 times 13,552, 62260. Is that right? 6? No, it's 6, 7, whatever. It's 6, 7. You could evaluate that. You could do 260 squared, and you could divide that all by 20 and then take the square root. But I'm doing it all in one step. Hit that, and I round it to at least 2 decimal places. So I'm going to go 2.83, and I'm done. Okay. Very good. Practice again. So I did it correctly. There's a third option you can take, and maybe I'll show that on another video. If you're not using the ALEKS calculator, and I don't know why you wouldn't, it's so easy. But if you have a TI-83 or 84, I will show that on a video that says sample standard deviation, um, TI-83, 84, or something to that effect. Let's do one more. So we have this. The following are the distances in miles traveled to the workplace by 6 employees of a certain computer company. So I'm going to hit calculator because I want the standard deviation. And I'm going to see how much I can do all at once. We want, how many values are there? There's 6. So I'm going to go 6. I'm going to go times. Then I'm going to hit this right here. All those things. Oh, it won't let me do it like that. So that won't work. I'm going to have to maybe use the store button. So first thing I'm going to do is I'm going to store the sum. There it is, 3688. Let's store it into the memory. Now it's in there. And now I can do, one more time, I'll clear it. And I'm going to do that again. And this number, I'm just going to write it down or remember it myself, 132. So 132 is the sum. And now I'm going to use the formula. The formula says it's the square root of the numerator, which is n6 times the sum of the x squareds, which we stored, and I'm going to now recall, there it is, minus the sum of the x's, in parentheses, squared, so 132 squared. Hit the wrong button. Try again. Okay, that, parenthesis, 6 times, recall, minus, what do we want? We wanted 132. Where's the x squared button? There it is. Close that parenthesis, divide everything by 6 times 5, right? N times n minus 1, 6 times 5. You could just write 30, but I'm going to do that. And it'll do this times that minus that squared and divide that result by 30, and it'll take the square root when I hit equal sign. There it is, 12.52. And that's it. Very good. You seem to have mastered this, and I hope you will master it as well. I hope it was helpful. Moving on. Talk to you later. Bye.